Here we are given the exponential equation 4 to the quantity 3x minus 1 equals 8. We are to find an exact solution in terms of logarithms and then the approximate solution rounded to 6 decimal places. Since we have a single exponential function this time, or a single exponential expression this time, I'm going to rewrite this in terms of logarithms. So we'll have 3x minus 1 equals the log base 4 of 8. This time, since 8 is the square root of 4 squared, the square root of 4 to the third power, which can also be written log base 4 of 4 to the 3 halves, we get that the log base 4 of 8 is 3 halves. So we have 3 to the x minus 1 equals 3 halves, which gives us that 3 to the x equals 3 halves plus 1, which is 2 halves, or 5 halves, or x equals 5 halves times 1/3, which is 5/6. So this time, without using a calculator, 5/6 is 0.83333. Now there is another way to solve this, and that would be by applying a log to the same base on both sides. If we do it that way, let's use common logs. We'd have log of 4 to the 3x minus 1 equals log 8. Then we can use the power rule that says 3x minus 1 times the common log of 4 would equal the common log of 8. And then we could have 3x minus 1 equals common log of 8 divided by common log of 4. And notice that gets us right back to where we were here. We could use the calculator to compute that, but we also see that we could compute it exactly. If I was going to use the calculator to evaluate this, first of all, I would get to the point where I had x equals 1/3 times log 8 divided by log 4 plus 1. So I added 1 to both sides first, and then I multiplied by 1/3. And on the calculator, we would then go open parentheses, 1 divided by 3, close and open parentheses, log 8, close parentheses, divide, log 4, close parentheses, add 1, close parentheses, enter. And there we get the 0.833 repeated again. So, two ways to do that. All right, let's go to the second example. The second example is a logarithmic equation with a single natural log. It's natural log of 1 plus x equals 1. So this is equivalent to 1 plus x equals e to the first power, or x equals e to the first minus 1. When we go to the calculator, this we can compute by going second log 1, close the parentheses, and I'm going to clear that because I'm not sure I did the correct. So second natural log, there we go, 1, close the parentheses, minus 1. Enter. So we're getting 1.718 3. We're asked to do it to 4 decimal points places, so the last digit is going to be a 3. We could also do this by exponentiating both sides. Base e, since we have the natural log, base e. Then the exponential of the logarithm cancels to give us 1 minus x equals e to the first. And this is what we had back here. The second method is required when you have more than one logarithmic expression. Okay, so here we have log base 3 of the quantity x squared minus 4x minus 36 equals 2. Single logarithmic expression, which in exponential form is 3 squared equals x squared minus 4x minus 36. 3 squared is 9. If I subtract 9, I get 0 equals x squared minus 4x minus 45. Or 0 equals x minus 9 times x plus 5. And so x equals 9, or x equals negative 5. And so there are two solutions here, and we can check those with the calculator by substituting.